Hello, today we have hello. Today we have some Leetcode problems we will try to solve. It's let me show my screen. So it's find all lonely numbers in array. You're given an array of integer nums. A number is lonely when it appears only once, and no adjusted number appears in array. Return all lonely numbers in nums. You may return them in any order. So because 5 has 6 and 8 and 10 are lonely. Okay, very easy. Let's do this real quick. So um, how we gonna detect? So for every element we will iterate. And we can create a set, right? Like from nums. No, they could be. It could be, but I think set will create correctly. So if it's one, it will be 135, and then for element in nums, what we're gonna do? We're gonna if set if element in set if element +1 in set or element -1 in set, then we probably do nothing. We have to construct result array, right? So if not, we add it to result, append, and we append element, and we return result. Wrong answer. Okay, so this could be a problem C because 1.5 is expected, output 135. 10, 8, 10, correct, 135. See, this is a problem, so we cannot find exact element. Yeah, so we have to think about it. Appears only once. Should we do counter and then filter only elements that appears on once? Yeah, if we have to do, let's do counter. And then for each element in ST, like k value, if value equal 1, so element appears 1, and there is no adjacent. Let's see. adjacent, and there is no adjacent element, then adjacent element cannot unpack into literal. Oh, okay, k value. Yeah, so let's do items adjacent. What? Oh my god. Okay, if items, if value. What is this? So let's print the string that we have. Key is element itself, right? 10 appear once, 6 appears 1, 5 appear 1, 8 appear 1. So for this is as well. 3 appears 2. So if value equal 1 and not, yeah, so we are not getting element, we are getting key, and key. Oh, I think it's pick up E element, E as a constant. This is so funny. All right, yeah, as it said, I think we solved it. Let's try it again. %. Wow, yeah, that's really good. Yeah, let's try another one. Adjacent. Okay. Implement the class Subrectangle Queries, which receive row and column rectangle as a matrix of integer in constructor and support two methods. Update subrectangle updates all values with new value in the subrectangle who appear upper left coordinate and bottom right. Get value, return value. Okay, it's very easy. Do this as well. So we initialize the rectangle with a list and we assign, let's call it data. Then get value, we return data row column. And if when we receive update subrectangle, we can update with the value for okay. So if we have matrix like this from data from 0 to 9, so if you have a matrix from 0 to 9 and here, for example, it will be 0 to 5, and we have 1, 2, right? And we have 8, let's say 4. It's a little disproportional, but what we have to do, we have to do 4 row from 1 to, so first set of coordinates we have, roll call is 1, 2, and then second we have 8, 4, right? So we start from 1, 2. Yeah, so we start with the rows. We will start with the rows like this. For row in range, row 1 to row 2. I'm not sure about inclusive things. For call 1, call 2. I think it should be +1. Is it like inclusive or exclusive? +1? Oh, let's do without first. Yeah, let's see. We have, then we assign self data. Sorry about that. Self data we assign with new value. And so data will be the same as this. I think it should be +1 because no. Okay, so return the current value is coordinate. Return the current value of coordinate row call from rectangle. Updates. I got it wrong. How it's possible? Ten, 5, 1, 1, 1, 1. So we in it with so first we create int with this data rectangle, right? Okay, let's copy this. So we had 3 by 4 matrix, right? And then we call what we call get value 0 to. And so how it's supposed to work if we got so if we say val equal and then here we print row call val and we return val. 0, 2, 2, and 1. Obviously, 0, 2 is 0 row, 1, 2, 0, 1, 2. Wait, something wrong with this. Why? The initial rectangle look like this. 0, so 0, 2, 0 row, 1, 2 column. Okay, 0 row, column is 1, which is correct. 0, 2, 1 again. Okay, returns 1, update structure 0, 0, 3, 2, 5. So from 0, 0 to 3, 2, let's print matrix, self data. Okay, 551. It's supposed to be everything 5. This is what I was saying. We have to be inclusive. And now it's working. Okay, so yeah. This is because how Python do range thingy. All right, it's accepted, but it's still not the best. I wonder why. It's not the best. Yeah, much better. 51 is okay, I guess. All right, should we do another one? Let's do another one. Adjacent. Find the prefix common array of two arrays. So you're given zero indexed integer permutation I and b. Okay, A and B. There are zero indexed permutations of length n. Prefix common array and b is the array C. Ci equal to the count of numbers that represent at or before index I in both S and B. Returns a prefix. The syntax sequence of an integer is called permutation if it contains our integer from 1 to 1. Okay, this is I understand. So we have permutation A and B. And so you'll get a prefix common array C, which Ci, this is important, Ci equal to the count of numbers that are present at or before the index I in both I and B. Okay, so yeah. So we have to count numbers that are present at or before index I. So 0, no number in common, 0, 0. 1, there are 3 in common. Oh, it's inclusive again. Okay, so possible solution that we have, what we can do, we can create a map store, right? Store A, store B, and then it's gonna be map for E in range. We calculate length of any array length. They are the same length, right? Yeah, the same length. Oh, let's call it n, as in our description. And then, what I would do, I would create default dictionary of integer, which is give. We don't have to check if value exists. Initialize with 0. It will be always initialized with 0 automatically, so we don't have to write this code. So then we add whatever we have. But see, this is like inclusive thing. So we have to add, first we start with 0, right? So we store A, oh, A0 to increase by 1. Store B, we increase by 1. Wait, store A, store B, we have I, then C, I, equal that thing, count of numbers that represent it before indexing both A and B. So how can I present count of common numbers? So common numbers, I can convert keys into set. Can I say store I common numbers, colon like Cn equals store I intersect with store I keys intersect with store B keys, and then whatever is intersection for I in for key in common keys, what I will do, I will if the running sum equals 0 and running sum plus equal whatever we have store A key plus store B key, and then our result which is 0, oops, sorry, 0 multiplied by n, or I should just append. No, result I. So here is summarized, and result I equal running sum, right? I'm not sure about if I can get keys in this way. Nope. Oh yeah, and I have to return result. Okay, so it's 0, 4, 6, 8. Yeah, it's twice as big. Why it's twice as big? This is weird. So if 1 and 1, they're just ones. Oh, they're permutation. You don't need this. You don't need, oh yeah. Oh, they're permutation, so that no duplicates is possible in that. I was thinking there are duplicates, but no, there is no duplicates in there. So yeah, always will be 1. It's overkill. This is what I did with calculating is overkill, but still 98%. Wow, I surprised. See, this is n by key and intersection of two sets, but 98%. How it's possible? Yeah, and it's working. So I don't need to count all this, but probably because it's only happens only one, this operation is okay. Okay, yeah, it's working, but it's have room for improvements. But that will be it for today. Yeah, thank you for watching. Yeah, almost 30 minutes. And remember today, today's word is adjacent. Adjacent numbers. Do it again. Very cool. All right. Thank you. Thank you, and see you tomorrow. Bye.